I would take this problem, if I'm looking for the closed form, and maybe write it as a T-chart. You know, you've done a lot of T-charts in algebra, X, Y. This is a T-chart where the the term number, I don't want to write N right there, I want to write term number. And the term, so the term number is the sort of independent variable, and the term is the dependent. And so when I had term number 1, I got 3. When I had term number 2, I had 7. When I had term number 3, I had 11. When I have term number 4, I have 15. Now the key to doing this problem is not to look at your final result, but look at how you got 7. And what did I do to get 7? I added 4 to the previous term. 3 plus 4 was 7. And then to get 11, I added 4 to 7. But 7 was 3 plus 4. So it's 3 plus 4 plus 4. And then to get 15, I added 4 again. 3 plus 4 plus 4 plus 4. To get the next term, the 5th term, which was 19, I took 15 and I added 4 again. And then to get the 6th term, which was 23, I said, well, that's 19 plus 4. And 19 was 3 plus 4 plus 4 plus 4 plus 4. Add another 4. Look for a relationship between what's happening here and the term number. Look at the number of 4s. What was it right here? 1, 2, 3, 4, 5. 5 of them. 5 4s. And what about on the previous step? There were 4 4s. How does this relate to the term number? On this one there were 3 4s. And that is 1 less than the term number. So it looks like I can do dot, 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 although this sequence, it's an infinite sequence, it continues forever. Then the nth term, and then I'll do dot, 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 because it does continue. The nth term would be what? 3 plus 4, how many 4s? N minus 1. So I can multiply, if I, you know, this sounds silly, me telling this to you. If I have 5 4s, I could say, well, that's 5 times 4, instead of adding the 4 5 times. So here I'm just multiplying. You can simplify this, 3 plus 4n minus 4, and I get 4n minus 1. So there's one way to do it. This type of sequence is a linear sequence, and what I noticed, if I was helping a student in 10th grade geometry, I noticed this. Although I don't have it, if I put the 0th term, term number 0, what would that be? -1. Do you remember this from algebra? Y equals mx plus b. Well, I would have y equals 4x minus 1. The 0th term, that's actually the y-intercept. And what is the 4 that I'm adding? That's the slope. That's the slope. So It's really a variation of some things you've done before in an algebra class, in geometry, in elementary school when you did sequences, although this goes a lot deeper than what you did back then.